anyway, I'm taking a break from this for a little bit, but there's still an issue with it. What was it? Oh yeah, the linear alignment doesn't appear to be precisely right. I mean, unless you look at it on the very slowest speed, you can't really tell. But I know the issue is there, and it's something I need to go back to, and also I need to go back and check the voltage in it to see where that stands. Last I saw, some of the places where it should have been 100 volts or 105 volts were actually 125 volts. So, and I think that they said that 15% was allowable, and this is actually 20%. So I don't know that it's off by a lot, but I understand that this type of equipment is pretty tolerant in voltage levels, but it's still another issue there that I'm not sure about. In the meantime, I got my hands on this little brother of the EICO. It's called an electronic switch, and it truly is an electronic switch, because switches at the time in the 50s and 60s were electromechanical devices, whereas this one has no moving parts whatsoever, and yet it's still analog. It doesn't do any type of digital switching. It's actually an analog electronic switch. And what's interesting about this particular one is that, this one I think was manufactured in a factory, because I've got this tag on the power cord. Basically tells you the model number, serial number 53, final inspection number 2, and then the initials of the person that did the final test. That's MC, or I don't know if that's the person or that's an abbreviation of the test. And what's interesting also is that there's no serial number on this one. I think a lot of them have a serial number stamped right here, and this one doesn't seem to have one anywhere on the face or anywhere. All there is just this piece of tape with this writing on it. Also, when I look at it, this is factory work. I mean, you can just tell by the way it's done. This was not a kit, although it was a kit, but you could have it manufactured in the factory. I think it was, I looked it up on the catalog, and it was like 30 bucks or something. There's also this testing. You wouldn't get a tested number on one that wasn't assembled. So this must be the serial number here, okay? Whatever B1009 is the job number. 488 is the name of the device, and 53 must be the serial number on this one. I just wish I could read the date that it was tested on there. You can't really read it. I don't think it's 60. It looks like it might be 1972. I'm not sure. I'm not sure how long they made these and why this would be serial number 53 if it had been made in 72, but you can't really make that out. Find out what the date is. It just didn't show up, but it's got the same initials or whatever on it. The way this thing works is there's a couple tubes that work together to generate a square wave, and it creates what the manual calls a multi-vibrator, and then that feeds off eventually through something called a follower, which looks like an amplifier to me, but it's called a follower tube, and then after that it goes into the mixer. So what it's sending is a square wave, and that square wave sort of oscillates back and forth. So there's two circuits that look identical. One is for one channel and one is for the other one, and generate some sort of a square wave. And then when it gets to the mixer, it'll mix in the actual wave that's coming in from whatever devices under test you have plugged in. And then it mixes them together and it puts them on a single output. You can see how it works here. there's the two inputs on this side, and they each have their own amplitude control. And then on this side there is a single output binding post, or set of binding posts, and then you can select the frequency that it's going to switch at. Now this is really just the frequency that it switches at. It doesn't do any type of introspection on what's being sent. You know, this payload isn't messed with at all. So even though this says that it goes from 10 to what, 2,000 cycles, and that's just the switching frequency. It has nothing to do with the frequency that's being carried across. The payload frequencies, whatever you have on them, you know, say you have 800 kilohertz, you know, that's gonna switch right through here. So I think, you know, just looking at this thing, I've inspected it. It looks like it's in pretty good shape. So I'm gonna go ahead and give it a test to see how it is. I'm not sure this thing has ever been used, to be honest with you. I mean, looking at it, the cord was coiled up perfectly, like it just came out of the factory, and it still has that tag on it. So I think I'll hook this up and see what happens. Okay, so I've got the EICO running, and I brought up the Hickok to generate the frequency and to provide the synchronized output. You can see that we're actually syncing off of the Hickok, not the electronic switch. So I'm just pushing one signal up to the electronic switch on channel 2, and then I'm just wired the two together. You can apparently use twisted pair on EICO products. And then I'm running the feed out here into the oscilloscope. So we'll turn this thing on, and hopefully I should see two traces show up over here. And it's a little bit bumpy. Let me try a different. Looks like a square wave. Well, it is a square wave that they send out. Okay, so you can see the, yeah, it's not too, okay. Now we're getting a little bit more here. Let me turn up the Hickok a little bit. Okay, so you can see that the frequency, like we talked about, of what, you know, the channels that you're actually sending the payload data is riding on top of a square wave, and that they are 180 degrees out from one another. I'm going to see if I can get this thing to come in. Okay, so we are synced off of the payload frequency now, or at least it looks like it. See what happens if I... Man, you can definitely see the way that the two channels switch. So let me tinker with this a little bit and see. Okay, it's getting closer. That still doesn't look too good. I'll do this fine adjustment here. A little hard to get it to come in, that's for sure. It's kind of cool though. Let's try a different frequency down here. Now it's so slow, you can kind of see it bouncing. You see how it's getting dimmer on the top, and then it's dimmer on the bottom trace. It looks to me like I may have to Let me try this, see what this does. That brings them together. And then, which one's the top and which one's the bottom here? Okay, the top is where it's supposed to be. Let me get them both set at the same thing. I did have them both set at 60. Now it looks like the top is a little bit weaker. Okay, and this separation really didn't move it down, so it looks like it climbs the ladder a little bit, and I'm going to have to play around with the vertical positioning myself. Try to get it centered a little bit better. Play with this thing a little more. I mean, that's the highest switching frequency that it goes at right there. And that's pretty, yeah, that's the thing. I'm only sending it 1,000 cycles. So let's go way above that. I mean, right here, that's 400 on the top end. So I think for 1,000 cycles you have to send it something at a slow switching frequency, because 1,000 cycles is pretty slow. It's kind of jumping all over the place. All right, so let's bump it up, make it 10,000 cycles, and then bump this up accordingly. You know, the bottom one doesn't look too healthy, does it? Let's bump this up now. Seems like there's no happy medium there. Let me turn up the intensity so you can see what's going on. And we'll try an even, nope, that's so high that it's, and let's turn this like this. Yeah, that's looking pretty good now. Holy cow. Okay, so that's 10K. Let's bump it up to 100K. I'll have to bump this up too. So there's a little bit of attenuation in the signal. You can see it. I think maybe if I add a little bit of power, yeah, I can get a little bit more out of it. I don't know how useful this is. All that does is separate the signal more. So it seems like my vertical gain actually separates the switching pulse, not the payload. Okay, and I'm having to use the power adjustment on the Hickok itself in order to increase or decrease the amplitude. But obviously there is some sort of attenuation taking place. I'll bump this up to a megacycle here. See, look at how small that is. You can't even see it. It's so small. Let me increase. That's maximum power on there. Yeah, maybe I can tinker with these. Yeah, I can get a little bit of amplitude. The signal's a little bit weird once you get up around a megahertz. So I'm going to turn this dial, move it up to 2 megahertz, see what that looks like. Okay, there's 2 megahertz right there. I don't believe I'm going to be able to get it much higher than that. I mean, I'm going to be able to increase the power much on these. You can see how my trace is cocked a little bit. That's because the tube is cocked. I finally realized, oh, there's no adjustment for me to fix that. It's that when they installed the tube cocked, and I'm not gonna mess with trying to straighten it out right now. Maybe some other time. I've seen people do that. What was it? Mr. Carlson. I saw him do that once. You know, you have to be so careful with these CRTs that I don't think it's absolutely necessary for me to do it just yet, but I might get around to it. But anyway, here we are, 2 megahertz. That's not too bad. I'm going to bump it up to 3, see if we can detect any signal at all. I mean, this is getting close to the maximum that the Hickok can. I don't know if that's a signal or not. Yeah, it is. If I could get it to stay in there. There we go. So that's 3 megahertz. And then there's a little bit of extra room on the top of this that'll take it up to 3.5. So I can see if I turn this all the way up, I get a little bit extra out of it, but not much. You can see that that's about the max that this thing can do. And I do get dual trace of it. So that's interesting. There's a lot of attenuation going on there. You know, you lose, I'm not sure what I've got here. Both of the signals, I'm gonna have to investigate that later. But I've plugged this into the top input. There's a bottom input there that I might be able to use as well, but the thing of it is that there's no protection. I mean, that thing doesn't have a capacitor or a resistor on that bottom one. It goes straight through to an RC pair. So I think maybe I probably should just live with putting it in this top one. That thing's hitting it with 200 and whatever volts. I think it was. I did get a voltmeter out and I measured it, and it was 250 volts, I think, something like that. All I did was just check to see that it was high enough voltage. You see how this has a serial number on it? This one does not. There's no serial number. There's no serial number on the top, which is where they put them sometimes, but this one doesn't even have a serial number on it. The date on it is kind of confusing. Maybe this is one of the last ones made or whatever. I didn't show you the bottom electronics on the underside. Maybe I should have. I'll take a picture of it and show it to you. But really good shape. I mean, everything just looks gorgeous. They did a hell of a job, you know. Yeah, see, that thing's drifting out. Oops, why don't I turn the right knob? That might help. But I'm kind of impressed. Let's change this over to a square wave. See what that looks like. It doesn't do anything, at least not at that frequency. Let me try sawtooth, no, or triangle. Well, what's the difference between the sine wave and a triangle at this? I'm gonna reduce it to like 10,000, and yeah, better go down a couple on this, and I probably want to turn this down to 60 or so. and reduce the power on here. And widen this up. Now that's not quite wide enough. Let's see what happens if I, well, that's its attempt at a square wave. That doesn't look too hot. And that's a sawtooth. I don't see anything any different there. Let's drop it down to 1,000. And drop this down. Yep. Well, you can kind of see a square wave there. A lot of noise too. And there's the triangles. So really it's a matter of I just had it on too high of a setting probably. So if I turn this down a little bit, let's see what the square wave looks like. Give it a little more room. Yeah, but you can see that they're kind of rounded. It's undercompensated on there. I went in and messed with this one and corrected a lot of issues with it, but I'm wondering if this is some sort of residual issue that I got going there. And see, that looks, well, it's because the amplitudes don't match, maybe. Yeah, looks like Charlie Brown's shirt to me. Anyway, kind of cool to play with. Turning an old-fashioned single channel scope from the 50s into a dual channel scope with this little electronic switch, which is fascinating. Yeah, because like I say, I worked, my working life was in the phone company, and I worked on, or I didn't work on, but I was around electromechanical switches a lot when I was young. And eventually when I did work in switching, it was a digital switch, so called a 40SS. And this one is totally electronic, I mean, it's pretty impressive for its time. Only 2 channels, and it's kind of like time division switching, but the thing that's different about it is there's no buffering going on. I mean, I don't think you could send data, 2 channels of data and multiplex them on here. You would probably, yeah, that'd play hell on data, but it would be interesting for audio probably. I wonder what it would do with audio signal if you tried mixing with it. Anyway, very interesting. Okay, I just wanted to shoot one more real quickie with this electronic switch. Now what I've done is I've run 2 different sources into it. One is the Hickok and the other one is the Heathkit. And I've got the Heathkit set at, what do I got it set at? Looks like maybe 130 kilohertz, and I've got the Hickok set at 200. And I run them in here, and I really am running the scope on free run right now. I don't have any sync source on it at all. Nothing on the horizontal input or external sync. And so I've just kind of got it dialed into channel 2, which is the Hickok on there. And the other one's coming in a little bit blurry, but if I mess around with the frequency on there, on the Heathkit, I can kind of dial it into a frequency where I'm showing 2 different sources now. It almost looks like that's close to twice the frequency, but it's not quite. Looks like it's maybe 1.5. Hard to tell, but to me it's kind of interesting that I can actually get 2 different sources through this electronic switch and put them both on the same screen. I can mess with this, change the frequency on the Heathkit, get it close to what the other one is. But like I say, it's actually kind of dialed in on the Hickok right now. I wonder if I could dial it in on the Heathkit. Yeah. And then just sort of play around with the settings on the Hickok and get it to come in. So that's kind of cool, actually. I was wondering if it would be possible to use two different sources and bring them together. It is, but you have to fiddle with it. I don't think it would be something that you could actually do very easily if you were just, working on something and then decided, oh, I need to read sources from two different devices, because really they would have to be pretty close to harmonic, a harmonic match or something to both be able to show up like this. So you can see a little jitter there on the one on the bottom, but pretty cool.